Thank you very much, Patrick. Very pleased to be here. This has been a year-long dream of mine since I was here the first time last year, so keep dreaming. Welcome, everyone. I am very pleased that so many people has come to join me in summer camp. Whoever went to summer camp? Show of hands. All right. And you survived. All right. That's good. That's good. We are going to go to a very special summer camp, Camp Crystal Lake. It is featured in most of the Friday the 13th movies. And over the next 50 minutes or so, we're going to dive into some, until now, undiscovered truths about Camp Crystal Lake in the fateful summer of 1981. We're going to look at Json. We're going to look at JQ, two types of Json. So not your typical horror story, but I promise it will be fun and scary. As Patrick said, my name is Ulrich. If you're into music, you may know the drummer, Lars Ulrich. He's also Danish. If you're into cycling or German, there's a German cyclist called Jan Ulrich. For some reason, I got it as a first name, but that still works. Hansen is a very widely used Danish surname, but the one in the middle is my wife's. And she told me that she just pronounced it in English like Obi in Obi-Wan Kenobi. So I said, yeah, I'll take that. That's fine. However, I probably wouldn't be very safe with a lightsaber. I don't play drums, and I do ride a bike, but mostly for transportation. However, I have a two-man shop with my man Kenneth, who's down there somewhere, and we love to talk about technology. So we've called ourselves Talk Tech. I still have to spell it out every time I spell that email. We do training for Apple, so all the way from consumer sales training to technical training, and we're also a Jamf training partner. But these days, we'll train in almost any MDM that people want to know about it. As Apple says, we don't care what MDM you use as long as you're using an MDM. When I don't do training, just like we learned earlier, it's important to also have a mental health and do other things outside of your work. I'm a huge foodie. I love cooking. I've even been teaching cooking as well. I love playing music. I have a background in boys' choir and musical theater, learning the guitar or really practicing the guitar a lot these days. And I'm a very late-bloomed gamer. Mainly got into gaming, only did like Commodore 64 back in the 80s, but as a way to connect with one of my nephews. And now I've ended up having like all the consoles. When you're adult and you can afford things, that can turn into an expensive habit all of a sudden. So I do want to give a little bit of a warning. You may have sensed that there is a horror theme to this. Just want to make sure it's all meant in fun. You will see some references, some violent imagery, just in case anyone stumbles across the videos of this later on the internet. Yeah, just be advised that there will be some references. And with that being said, I'm not trying to claim any copyright over anything. The names and the characters that are referenced in this presentation are, of course, still the owners of the original copyright holders. All right, the theme is going to be Friday the 13th, but again, we're also going to talk a little bit about horror movies and how there is a, until now, undiscovered correlation between horror movies and the Unix terminal, the command line interface. So we're going to do a little bit of a history, taking a look at these until now undiscovered correlations, just talking about what are some of the things that happened in the history of horror movies and the command line tools. Then we're going to go to Camp Crystal Lake and figure out what is a JSON file. There's been a couple of references so far in this conference, but I thought it was a good idea just to kind of break it down, because in technology we can't know everything all the time, so good opportunity to just break down what is a JSON file. And then, once we have that JSON file, we're going to chop it up into pieces. Our killer is going to be JQ. It's a new command line tool or binary that was included from macOS Seqouia, so now it's there. We're going to use it to help our Crystal Lake killer find his perfect victim in the JSON files. And then, yeah, no, it's going to get boring in the end. I want to take that into the real world as well and show you where can you use JQ, and it is really good for parsing data you get back from a lot of APIs, as they are often giving you data back in JSON. So that's the plan for today. If anyone has flashlights, it gets really scary. It's okay to hold the hand of the person next to you, but yeah, let me know if we need to tone things down. So first, a little bit of history. Some of us, not all, and I'm never going to assume anything, and I'll try and explain everything that I go through, but some of us might be familiar with some of the Unix and command line interface tools that have been around for a number of years. And there is this theory now that computer historians have started to uncover that there is a strange and unnerving relationship between very useful terminal commands and horror movies from the 80s. No one has dared to talk about this publicly, but I'm being brave for science today, so we'll see how it goes. If I'm still here tomorrow, then. So in 1980, the world saw, or the cinema saw, the first Friday the 13th. This wasn't really Jason, the later Crystal Lake killer, but it turned out it was his mom, blaming camp counselors for the accident of her son's death. Then in the end, in the twist ending, he rises from the lake, and then he does the killing in the rest of the movies. Now here is where it gets strange and a little scary. At the same time, the end of the 70s, there is a terminal command that is starting to become very popular, awk. And we all know the manual says it's a pattern-directed scanning and processing language, but what does it really do? What does it really do? It slices up things, just like JSON. I'm just saying. Coincidence? I don't know, I'm not sure. Later in 1984, we saw the first movie in the franchise, Nightmare on Elm Street. And this is something you have to be a little bit of a horror fan to know, but Freddy Krueger, who was the killer in these movies, he wore a red striped shirt. And at the same time, commands like grep and cut were getting famous. And grep is really, oh, too fast. Grep is really a search tool, isn't it? And who else wears a striped sweater? Well, that would be Where's Waldo, who also searches for things. All right, let me go back here. So another strange coincidence. Now, grep was good at searching, but it couldn't navigate nested structures. So we needed something else as we move along. Let's see my big, there we go, get away from there. Then 1999, things changed. The horror genre is redefined, a new era of horror. And at the same time, XML was introduced. And you might say navigating through XML was a little scary, just like shaky handheld camera footage navigating through the woods. So there was a strange correlation there. Fortunately, XML was then also updated in some way, and we saw JSON files come along that presented it a little more readable, but it wasn't really all there until 2012. At the same time, we saw a new type of horror movie called Cabin in the Woods, highly recommended. It claims that there was a deeper meaning behind all of these horror myths, that there was something going on. Everything was done for a reason. And then at the same time, we did in fact see the first version of JQ. And now, JQ is built into the command line on Mac. So I thought, great time to explore that. Who has heard of JSON? Not the file type, but the Crystal Lake Killer, the old 80s Friday the 13th movie. Okay, I was telling one of my friends about my idea for this presentation, and he said, won't the crowd be like way too young for that? And I said, yeah, they'll be young, but I think they'll know JSON. But then, of course, he teaches high schoolers, so I would have had to come up with an analogy for how JSON files would relate to TikTok. And this one was easier and more obvious. So I'm glad that you've heard about Json. Who is he really, or what is it really, JSON files? So it doesn't stand for JSON's object notation. It is JavaScript object notation, but not really any JavaScript in sight. But you can think of it kind of a digital camp logbook. So everything that happens at Camp Crystal Lake, who is the head counselor, what year is this camp running, what are the shifts, what are the other counselors at camp, that all goes into a structured files that both humans and machines can read. JSON is a very universal format of data, and it's used a lot of different places. Applications use it, websites often, Apple Business Manager. So we're going to use the camp to build out a JSON file, one creepy entry at a time. So if we take a look at a computer, let's say we have a summer where someone in camp is doing computer basics, and they're going to build everything from that manual logbook into a file. It would look something like this. Probably a lot bigger, but I'm going to show little bits at a time. It's a flat JSON object, single page. It contains key value pairs that we might be familiar with from XML files as well. But the syntax is a little bit easier to read because we don't have the open and close brackets everywhere that we see in XML. So if you note a little bit around the syntax, the entire thing is enclosed by two curly brackets. And then every key will be in two quotes and have a colon in front of it. The values could be different types of values. It could be numbers, could be strings. And do note that strings will have quotes around them as well. That's very, very typical for strings also. So that could very easily be, again, Boolean values, something like true or false. Well, those are the only two options. Or empty values like null are lowercase and no quotes. So easy to read, both by humans, machines, and of course then deranged killers. Very important in this story as well. So just some of the data types that we might encounter and some example elements. We could have something like a string. That could be attribute could be something like the head counselor. It will always be in quotes with a colon. Value could be a string like Crystal Lake, text in double quotes. We could have something like, I can't read that, I'm really small here. Numbers, no quotes. 1981 is the year we're going with. Digits, no quotes. Boolean, true, false, all lowercase, no quotes. Or no value is also lowercase, no quotes. Cool. So we're going to dig a little bit deeper into the JSON file because we can have nested structures. So sometimes to organize things, we're going to be nesting things. And now we have some, in the big camp file, we have our own nested data. In this case, information about the counselors. And there's going to be more than one counselor at Camp Crystal Lake. So we are creating an array of counselors. One of those sentences I never thought I would say. And it's like a litter of kittens, an array of counselors. Yeah, kind of like that. So once again, we're creating one whole new object, and it's enclosed by curly brackets. And then counselors, the array, we use square brackets to indicate that here is an array that's starting. So let's try and zoom into the array so we can read it a little bit better. Try to build these screenshots so it would be possible to read it on a large screen. We could have multiple counselors. Each of those counselors would be an object, so represented with curly brackets again. And then a lot of information. Often you may have something like a unique identifier, some sort of ID. You could have information like a name, maybe an age, where we have those different data types represented. And this just shows us 2 out of, I believe, currently when our story begins, there are 7 counselors. May not be the case all the way, but these are only 2 of them, Scott and Terry. For one of those counselors, if we zoom into Scott, we could have more than just name and age. For instance, we might want to know what their schedule is. So in this case, it's the evening shift. We might want to know a little bit about their love life. You know, it's not really an 80s horror movie if there isn't a little bit of romance. So we create a new object, a relationship object, which is now, follow along, we have the camp file, we have camp data, that's nested, then we have counselors, it's a nested array, and in each counselor we have relationship. Could contain a lot of different status. The one that's interesting in the context of the movie is, of course, romantic interest. So now we know that Scott is romantically interested in Terry. That might be interesting for later. So we can mix all of these data types. We could have integers, booleans. We could have a nested object like location that contains items like keys like longitude and latitude. Very well labeled. You will always know where to find everything in a file such as this. So, while JSON is one of the OG killers that we've heard about, the data type JSON can be used for many different things. It's very often, as I said, the data structure you get back from things like Apple Business Manager, Jamf Pro, Intune, if you're accessing over the Graph API. It's very powerful. It's very, oh, sorry, that was the next one. I wanted to make sure that we just understood how a JSON file is built, because otherwise it's going to be a little more difficult to explain how JQ fits into this. Cool. So if the JSON file is our creepy camp logbook, then JQ is the chainsaw or machete that we're going to be using to cut straight to the part of the JSON file that we care about. JQ, that's going to be your lifesaver at Camp Crystal Lake. Not really. It's going to be in Jason's tool to find his perfect victim, but yeah, sure. Of course, your lifesaver, not the victim, but here. JQ stands for JSON Query, and as I said, built into macOS from Seqouia. And is Jacob Burley in the room? It was a student in one of my classes that made me aware that it was now in, up there. Thanks, Jacob. Less than a year ago, we were parsing JSON files with plutil, and he goes, "Why aren't you using JQ? Why I'm not using what?" So built-in and really good at parsing JSON files. You can think of it a little bit like grep or awk. I know I made fun of them in the beginning, but they are, of course, pattern recognition tools. But it's really good for structured data. And it has some built-in functionality like looping. So if we have an array of something, we might want to loop through that array, and that's built into JQ. So we can save ourselves a lot of lines of scripts. Very lightweight, very minimal syntax, but very powerful as well. Oh, there was one more build. Now for the next section, if anyone, or you don't have to be new at Terminal or new at JQ, but I am also a trainer and I love to help people learn. So if anyone wants to follow along, you can download the Camp Crystal Lake JSON file from JSON without an A, jsonlives.com. I'm also going to put the presentation and some of the demo files I'm going to be using in the API without the secret tokens, of course. You can put in your own if you want to play around with it. So if you want to follow along, you can download it from the big red button on the top of here, Get the Demo JSON. I did put it in a zip file because otherwise it'll just display the JSON file inside of Safari or your browser. But if you download it, you could jump then in Terminal directly into the folder where you've downloaded it. That would typically be the downloads folder. So if you open up Terminal and you're not familiar, I'll slowly take you through using Terminal for this as well. But we do need to navigate for making it easy, navigate into the folder where you've downloaded the JSON file to. So something like change directory into your home folder, downloads folder. That way, all the commands I'm going to show will you can use the name of the file. You don't have to put in the absolute or the relative path to the file. And that makes it a little easier. Also makes it easier for me to fit it into my slides. And of course, you can play along after if you're watching the recording or something. So I can't show the entire JSON file. It's big. I did get some AI to help me create it. The AI knew more about the movie than I did, and then I've used it to play along. So I'm just going to show whatever part of the JSON file is relevant to our command. But let's pick up the terminal and start slicing through the file. And it starts with jq. That's what we would call the command, sometimes referred to as a binary, but it needs some sort of options, and then it needs a target. Now, the options we put between two single quotes. And be careful if you're ever copying code, single quotes and double quotes on Mac are often converted into what's called smart quotes, and they do not behave in scripts or terminal as they should if they were regular quotes. That's a thing that took me many hours of troubleshooting to realize originally. So we call that the filter. And the dot represents the root of our document. So the year is referencing the year attribute. That's all we're going to do. We now just need the path to the file. And if you've successfully navigated into the same folder that we downloaded the file, you can just put in the file name. Otherwise, you would have to put in the entire path. Another good trick in terminal is if you type something like CA or CAM, the beginning of the file name, and you hit the tab key, it should autocomplete if it's finding the file in the expected location. So you run that, JQ, filter is just looking for year, and then the path to our file. We hit enter, and we get 1981. It's pulling that one attribute out. Fairly simple. Next, let's take a look at one of our counselors. Let's take a look at one of the counselors. We still have JQ, and then we're going to start navigating the nested structure of the file. So we need to open up our filter with a single quote, and we now use the .camp data to start digging into the nested structure of the camp data. And in there, we had the counselors as well. So that's campdata.counselors. And now we've hit an array. We have 7 different counselors, and we need to figure out which counselor are we currently looking at. So we put the number of the counselor inside of square brackets. And I know Patrick said that maxsysadmin is one array, but I do apologize, Patrick, but JSON is a 0 array. So we do start at 0. You typically refer to it as a 0 index or a 1 index array. And that can really change up things. And note that even though Scott has an ID of 1, that's a unique identifier that the camp uses to identify him, but his position in the array currently is still the first position, which would be 0. So that's how we reference that. Now, after that, we can go and add an attribute that we're looking for. So if we wanted name, we would then finish up our filter with .name, close it up with a single quote, hit enter. We need a space. We need Camp Crystal Lake. And if anyone, again, is new in the terminal, all of this is still in a single line of text. It's still one long command, but if your terminal window isn't long enough, it's going to do automatic, not a carriage return, but it breaks the line to the next, but it's still going to be executed as one command. So you have to get used to that sort of going to the next line. Now when we hit enter, we get back Scott Cheney. So that's digging a little bit more into the structure of our JSON file. So one of the cool things, as I mentioned, is we have built-in looping. Because if we wanted to grab the names of all counselors, if you've ever done something like that, you have a big bag of counselor names, I typically say, and we can use a for loop and loop through. But we need to write a couple of lines of code to do that. But that's built in. We do JQ, we dig into the JSON file, the nested structure, camp data into counselors. And if we put the square brackets but we just leave it empty. That means it'll just automatically iterate through that entire array. That's the easiest loop I've ever built, I have to say. So we finish it up in the same name. We say, go through every counselor, and for every counselor, just give me the name, and we close up our filter. We put a space and the path to the file that we're parsing, and there we go. We have all the names of all the camp counselors. Very easy, right? So, we're not here for fun. We need to help our Crystal Lake killer figure out who's it going to be fun to kind of pick as a target. And Json is very structured. The killer, well, the file type as well, but the killer. So he has some very particular needs that he's going to go by. He's sneaking a peek into the log file, and he's thinking, what are some of the attributes that would be perfect for finding a victim in this case? And he's thinking, I'm going to be politically correct, and I'm only going to go for someone over the age of 21. They're more experienced, they're more likely to venture out into the dangerous parts of the woods. So he's just really interested in the names of the counselors and their age. He doesn't need all that other information. Well, we can help him. He's not that good at computers, so we're going to help him a little bit. We're going to build a JSON file for JSON. Yeah, I said it. Sorry. And we start the same way. We say JQ, and now we're going to say camp data, counselors. We're going to loop through the entire array of counselors. And we have now the pipe. So if you're not familiar with the pipe, it's a very powerful tool in scripting and terminal. As I said, I'm a big fan of cooking, so I like to use a cooking analogy. If you have a big commercial kitchen, often you'll have stations in the kitchen that do different types of work. So 10 kilos of carrots or bananas come into the restaurant, and you have typically one station where they're peeling all the bananas. Now, when everything is done, you have a big pile of peeled bananas, and they're passed on to another station where someone then chops or mashes them up. The pipe character kind of works in the same way. We have all the output of the first part of our JQ command, looping through the counselors, is now sort of handed over to a second station that's going to do something else with it. And what it's going to do is it's going to build a new object. So we're using curly brackets again to build a new object, and we're just creating our own keys. We're going to use similar keys, but we just need the name. Then we're going to fill the value of the .name attribute. That's where we are in our parsing. And we need the age of the counselor. We're going to fill that with the .age. And then it's going to do that and loop through the entire array of counselors. We close up our filter, and we have a space and our target file. And if we run this, now we get a whole file. You can't see all of it on this shot here, but if you scroll up, if you're following along, you would have all the 7 counselors and their names. Cool. Well, by the way, this is not changing the original file. We currently just have the output inside of terminal. We could pipe it out somewhere else, but Json is fine with this. He can carry it along. But he was only interested in those counselors that were above the age of 21. So we can adjust the filter a little bit. He's not just a mindless killer, as I said. A couple of things are going to make more likely victims or better victims someone who is more likely to venture out alone, who feels confident. So we're going to filter over the age of 21. And that is a built-in function, again, into JQ. So we're piping the array of counselors, and now we're going to use a select tool. You can think of it as an if-then statement. It's simply saying select anyone from the from the counselors array where the key age is above 21. So simple, we're going to get rid of some of the counselors and then keep some of them, and then once again, we pipe that and just give us the name then. We don't even need the age attribute this way. We just get a list of names, and now we know that everyone on that list is above 21. Once again, a space and the path to our file. We hit enter, and we have 4 out of the 7 counselors. So we're getting closer. So many choices. Json still doesn't like that, the killer. I don't know about the file if it has tastes in that area. So he's going to take a look at the counselors again and see if there's something else that might be useful for picking your victim. Someone who's working in the evening, definitely. We don't want someone who's gone to bed early. He is nocturnal after all, Json. So someone who works in the evening, and then someone who has a romantic interest is also going to be more likely sneaking off into separate areas of the woods. So that would be 2 additional filters that we could use. So if you, again, just to throw in a little bit of learning here, if you're new with the terminal and you have a lot of text and it gets confusing, it gets bogged down, you can use Command K. That clears up all the text in terminal. And then you can save some time. Instead of typing out, we're going to use most of the command again as well. You can use the up and down arrows to traverse your command history. So arrow up would bring back the entire command that we ran just before. We do need to start typing somewhere in between, so I'm going to go all the way back to the filter, and I'll show you another trick later on. But we still have our filter. Select anyone where the age is above 21, and then we're going to add the dot relationship. And remember, relationship was a nested object as well, so we need to go one more level into that and say the dot relationship dot romantic interest cannot be null. So it cannot be empty. We need someone who has a romantic interest. And then, of course, the Camp Crystal Lake. Now that leaves us with 3 people, but you can see that some of them have the afternoon shift. So I'll do a Command K, once again clear, arrow up, and instead of deleting in a long command, if you want to place your cursor somewhere, you hold down the Option key, and I'm going to click at the parentheses because then I can add my final search term or my final filter in there. Now, I couldn't animate the text moving. It's just going to push everything in front of it, but you do add another and we want the dot shift value, the dot shift attribute, to be evening. So we're sure that we have anyone who is above 21, who's in a romantic or who has a romantic interest and has the night shift. And if you hit enter, well, we just get Scott Cheney. And apparently that's the reason that he's the first victim in the Friday the 13th part 2. It was Json, the file type, and the killer too, of course. All right. So alas, Scott is no more. We should probably purge him from the file. Json is ruthless. So we can, again, use another JQ command called delete. And we're going to go into the counselors array and use the select command this time. We could probably, in APIs, you would mostly use a unique identifier of some sorts, but we're just going to select Scott Cheney and then the path to the Camp Crystal Lake data file. And we then get, in fact, the entire file outputted into the standard output, but it's now without Scott. So what we could do is do something like count how many counselors are left, so we know how much work Json still has to do, which could be done by taking the command from before, selecting where Scott Cheney is deleted. But now we take the pipe and we look in the new file that's created. We find the counselors array. We're looking at the whole array, so I don't have the square brackets. And now we're just looking at the length of that, how many objects inside of that array. And there are only 6 counselors left. All right. So just to recap that a little bit, what have we seen? We have seen what we call array iteration, looping through something like an array of counselors using the square brackets. Json is very thorough. He's checking every cabin. We've seen using a filter, so selecting any counselor where the age was above 21. We have seen, I can't read that up there. We've seen a null check, making sure that romantic interest is not empty. We have seen a match, so something like selecting an array where the shift is evening. We've seen combining filters, so we could use and or inside of the filters if we wanted to, so age above 21 and shift evening. And we've even made the kill in the JSON file, deleted data. Oh, and counting. We need our body count. Well, so it's going the other way. Survivor count, I guess. And let's see. That's good for timing, because I hope that's kind of enough explanation to understand what's the JSON file, how can we then use JQ to parse all that data. It's time to say goodbye to Camp Crystal Lake and go a little bit into the real world and look at some real world use cases. I think you can see how effective JQ can be. So I'm going to spend a little bit of time going into APIs. And yeah, I can do that. Just in case you've never used an API, you may have heard it. It stands for Application Programming Interface. And it's a way of interacting with a service. I'm going to show Apple Business Manager and Jamf Pro and Intune through the Graph API. So we have interacting with those services without logging into the graphical user interface, but interacting outside, so you can do it programmatically through an application or a script, third-party tool, and that means you can automate things, so you don't have to log in and press buttons. A good analogy that's often used is the restaurant experience. If you compare going to a restaurant to cooking your own food at home, which I love, but still, it's kind of like at home you have to go to the grocery store. You do have to go to the restaurant as well, but you go there and you're almost ready. If you're cooking on your own, you have to search every aisle for different ingredients. At the restaurant, they just hand you a menu. You pick from a list of items. At home, you then have to get the food home, so there's some sort of payment going on. I know you pay for your restaurant visit, or you should at least, but I just wanted to bring that in because when you arrive at the restaurant, typically you have to prove that you made a reservation and you show some sort of ID to prove who you are. Yes, I did make a reservation, so I'll use that analogy. You have to then bring all the ingredients home, drive home, where in the restaurant you just tell the waiter what you want, you pick from your list, and finally you have to cook everything yourself. In the restaurant, the waiter just goes away and magically the food appears at your table. And this is kind of the same experience you have with an API. And we have some different parts of the API that we can then use to reference. So walking into the restaurant would probably be your curl command. I'm going to use bash for this, or zshell. That will be the tool that makes the request. And you can typically use your programming language of choice for this. Then showing your ID, proving you have a reservation. We need some sort of authentication going on here when we make a curl command. Prove that we're allowed to order, prove that we're allowed to receive our scrumptious data. Looking at the menu is very much what we call endpoints in APIs. So the different types of data that the API supports sending back to you when you request information about it. Specific objects. So computers in your Apple Business Manager or MDM servers you've set up in your Apple Business Manager would be endpoints. Telling the waiter your order, that would be making the request. And we're going to focus on the GET request, getting data, but typically you could also create new data, you could update existing data, and you could even delete data through the API, assuming you have the required privileges to do that, of course. So that's asking for what we want back, and then when dinner is served for you, well, we get our JSON response back. If that's the data type that the API supports, which in this case would be kind of stupid to pick other APIs for this demo, that's the data that we requested. Okay. Now, we saw how things went earlier today. I had a long conversation with Mark over lunch. he forgot this part, a sacrifice to the demo gods before I'm going live. I thought long and hard. I had to watch the entire movie series, Friday the 13th, to find something that fitted a worthy sacrifice. And I found it not for copyright purposes, but just because it would be too graphic. I don't want to play it, so I will, like Armin did yesterday. I'll have to describe it, and maybe you can guess a part of it. It's in Friday the 13th, the final chapter. It wasn't, by the way. There were many, many more. There is a scene where a hitchhiker is trying to get a ride from our protagonist, just laughing at her, pointing, and she gets frustrated, and she sits down the side of the road and has a snack, completely unaware that Json is right behind her, and finishes her off. But the real question is, what is the snack that she is sitting down and having? What is the fruit that is squished in her hand in her final death throes? Any guesses? It is indeed a banana. So yeah, I think I might link to the YouTube clip on the website as well. So I figured that would definitely be a worthy sacrifice for this. So I have a little prayer. You can hum along if it doesn't collide with any religions out there, of course. Dear demo gods, accept this sacrifice of Banana Girl, single quotes, by the way. Let her death not be in vain, and may the 3 demos that follow be as swift and clean as Jason's blade. So with that being said, I am going to venture into a couple of demos just to finish it off. It's not, well, I need to live life risky as well. So I'm going to start with Apple Business Manager. Let's get down to business. And there are so many screens here that finding your cursor is like the beginning of the demo. And let me just mirror my display. That should help a little bit with the resolution and being able to see what's going on. Cool. So as I said, I'm going to put the full demo scripts and my token generation files on the website as well. I'll strip all the client IDs and secrets and everything that's been used to create that. I did also link to Bart's website, there we go, with a very, very easy getting started guide for getting your API token from Apple Business Manager and generating a text assertion that needs to go into the file. I think there's a Python script and a shell script that I used for that. And just so I didn't show all of my tokens on screen as well, I've simply just sourced the file with all the token generation into external files. And I have a function called access token that should generate a valid access token and store it in the variable called $access token for this. So anytime I'm doing anything with an API, I always like to just check, do I have an internet connection? Am I getting a valid access token? Yes, I am. I am getting a valid access token. Otherwise, the rest of the demo can be a little bit troublesome. So one of the bits of information you need to include in your token generation script is like the ID for your Apple Business Manager. So everyone goes to the same URL, api-business.apple.com. And at the end here, let me move this down a little bit, that's typically what we refer to as the menu. That's the endpoints we're looking for. So they're called org devices if we want a complete list of all the devices in our organization. And there we go. We have a big list. As I said to Kenneth, I couldn't really figure out how to, I won't show any other serial numbers. And when we get home, we have to figure out whose Mac Studio was it that I showed. And I guess they have to get a new Mac Studio. Now it's compromised. I know Patrick Wardle will tap me on my shoulder and saying, I own you now. But yeah, that's the only way. As you can see, we're seeing some of the things we talked about. We're seeing that bracket, that's the entire object, the entire file. And then we're seeing an attribute called data that starts with a square bracket. So that was an array. That means that the array that contains all the computers, all the devices from our Apple Business Manager is called data. So if I wanted to reference that, I could reference it using data. Okay, so if I just wanted to see more information about one computer, the first one in the array, well, I could use JQ to do that. So I would do the pipe, I could type JQ, and I could say dig in, I'm going to use that filter, the double quotes, dig into the data array, just like we had counselors before, and show me computer number 0. So now, and just a little thing about the pipe is I'm using it this time before the JQ, so it means that this entire file, that whole file that came out, I'm taking that, and it's kind of like that would be my Camp Crystal Lake file that came after here. I'm just bringing it from behind me and then parsing through it with JQ. So if I run that, now we just get that one computer and nothing else. You do get some additional statistics here about that. That is something you would often silence in a curl command with a -s. And then you can see we have all the attributes here. So typically some of the things you would see in Apple Business Manager, product family, order date time, colors, Wi-Fi addresses. Not all of it is filled these days, but as we heard yesterday, more information is coming. Let's be careful here for time. So just as an example, I could create my own little file as well. I could iterate through all of the computers, all of the devices in my Apple Business Manager and create a new little object if I wanted to. That would not be square brackets. That would be in curly brackets. And I could say something like, what do I want? I want the model, for instance, of one of my Macs. And let's use something like product family for that. So we are in the data, the nested structure called attributes. So I have to remember that when I type it, attributes and then dot product family. That's just going to be my model here. And what else would I want? Something like the status. Is it assigned to an MDM server or is it unassigned? So attributes like that, and then it is called status. So that's something that could be interesting. And I need to close up this filter again, and I have double quotes. Now all of this is now a multiple restaurant station. So I'm getting all of my devices, looping through them, and then for every device I'm printing out the model, the product family, and the status, so I can see whether it's currently enrolled or not. See if I made any typos. I did. A pipe too much? This one? Oh, thank you. No, that's not it. Data, I do need the pipe. Status, access token, JQ. I have model attribute products family. That's going to be the model is just my name. Not yet. I wanted to do that last. So attribute device model product family status. Oh, thanks. That's it. That's the one. Status, and I'm assigning the status of the. And then I do think I do need that pipe because it's performing another. There we go. So now I can see the individual device types and whether they're assigned or unassigned. And then exactly, that would be a filter that could be very useful to run. So maybe we only want to select the devices that are currently unassigned to make sure we need to do something with that. So I could add that filter in here and say, before we create the list, let's do a select, and let me open and close that up. And my filter in this case would be, give me anywhere where the attributes, I keep thinking yesterday saying nobody wants to see you stand and type, and here I am doing it. Attribute status equals, and then I'm going to do the unassigned. Like that. That should then give us any of the devices in my Apple Business Manager that are currently unassigned. Yeah. Thank you very much. 5. All right, let's see, let's see. We'll, just to show anyone who's attended any of the Jamf, well, the higher level Jamf training where we do APIs, you would get something like buildings and get information about all buildings. And we have, again, one long array with all the buildings. We have the total count, but the arrays in Jamf Pro are always referred to as results. So we could use that same built-in looping functionality. Instead of writing a for loop or a while loop or something like that, I can just pipe that into JQ. And in my filter, I'm going to say, run through the results, the dot results. That would be the array of buildings that I have. And then for every member of the array, we are just going to pipe out we're going to print out the name. Like that. No, that's not the loop. That would be a particular one. Yeah, let's just do the names like that. The dot name. That should work as well. We have, oh, let me silence the statistics. So we have all the names, but we could use a filter here as well and do something like, let's just select the buildings that are in the US. So in the filter, we would say go through results and then do a select, oh, that's before, anywhere where our dot country equals USA. And we close up the filter here. And then once we have that, let's put that into a little file that says, let's say name. Building would then be dot name, and country would then be dot country, like that. So we're creating a little file with the names of the too many people at the same time. Country colon. Thank you. Yeah, live debug. You guys, I should have you guys with me all the time. And we get the 4 buildings that are located in the United States. Excellent. I have 2.5 minutes for the Intune demo. This is getting all the devices in your organization in the Graph API. And I wanted to show that you don't always get a nice, cleanly formatted JSON file back from all systems. That's one of the built-in features of JQ. You can just pipe everything through JQ. This basically means that we are using the root level of the document, the filter instead, but it's inferred, I think. So if you just pipe it through JQ, now it's formatting in a much nicer way like that. If you don't like the colors, there is a -m function for monochrome, and you just get it much more like a regular file here. So that's a pretty cool functionality as well. And let me show the final one. We could do something like piping it through, and just to show you, you have to figure out what is the name of the array of the computers. Oh, I'm going to do this. And in this case, the array is called value. That would be, again, the array of all the 14 devices in my Intune here. So I would do a filter called dot value. And I could do something like group. So it's kind of like sorting all of your computers. We're going to put them in groups. And we're going to group them by a sometimes interesting attribute, the OS version here. So group them in OS version. Anything that's running, 15.7 will be one group, 16, and then 26 would come later down. So we have those different groups. And let's pipe that into one more thing, because we now want a small file. And we can map all of these groups, and we want them divided into the different OS versions. So that's not the original array of computers, it's the array of groups. I don't know how many groups I'm getting, one group for each operating system version. So I'm going to map those and create a small file, and I'll start at the very first group. I don't know what, what version it'll be, but I know it'll be the first group, so it'll be 0 because it's a 0 index array. And then I want to print out the OS version. Oh, and I should give this an attribute. Let's call it macOS. Remember the colon. So that would take the OS version of the length, and then I want to see how many computers are currently running that particular version. So I'll do a count, and that will then be the length in that particular array. So that group, that particular OS, how many computers are in that group? Let's see if I did any typos. I did. Count length OS version. Oh, that's like one I get wrong 8 out of 10 times. LENGTA. That is correct, right? Count length. Should be good. Oh, I know what I'm missing. I am missing the map here has to be in a parenthesis to map those groups inside. And now I can see that I have 2 computers running 15.3.2, 10 computers running 15.5, and 2 running 26. And that, ladies and gentlemen, is me being a minute and a half over time, but thank you very much.